Today's topic is atomic radius from class 9th, chapter number 3, periodic table and periodicity in properties. So before discussing atomic radius, it's necessary to know about the structure of an atom. Atom is made up of nucleus and electrons. So now nucleus consists of proton and neutron. It is a dense part, hard part which is present in the center of an atom, while the electrons are revolving around the nucleus. Always remember, electrons are not revolving in circular orbits. They are revolving in three-dimensional orbits. So the orbits which are present around the nucleus are spherical, and the electrons which are revolving in the nucleus are not at fixed position. They are continuously changing their position. So don't you think, so how can we think that any body which is continuously changing its position can be taken as a standard to measure the boundary? Never. So that's why we used to take the half of the distance between the nuclei of the two atoms to measure the atomic radius. Why it is difficult to measure the size of an atom? Have you ever seen an atom? Never. So please memorize it. Atoms are small in size. Electrons in orbits show three-dimensional motion. Atoms don't have fixed boundaries, and electrons have probability of finding anywhere around the nucleus. So if atoms don't have any fixed boundary, how can we take a standard to measure the size of an atom? So that's why we used to measure the size of an atom by means of distance between the nuclei of the two bonded atoms. There are two types of forces present among the atoms: attractive forces and repulsive forces. So the attractive forces are present between protons and electrons. They both are oppositely charged particles, so definitely they will attract each other. And if the number of protons will increase, the attraction will also increase, and it will decrease the size of an atom. While if I talk about repulsive forces, so the forces which are present among the electrons, as both are negatively charged particles. If I talk about forces between electrons or between protons, like in this way, the force which is between electron and electron or between proton and proton, so that will be the repulsive force. As they both are same charges, so they will repel each other. As there are infinite number of orbits are present around the nucleus, so we will not take electrons or the orbits as a standard to measure the size of an atom. So half of the distance between the nuclei of the two bonded atoms will be considered as the atomic radius. Now here the d stands for the distance and r is the radius. So d by 2 will give us the atomic radius. What are the units of atomic radius? Atomic radius can be measured in nanometer and picometer. So here the nanometer stands for 10 raised to power minus 9 and picometer stands for 10 raised to power minus 12. So now if I talk about carbon atom, the distance between the nuclei of the two bonded carbon atoms is 177 picometer. And if I used to take half of the distance between the nuclei of the two bonded atoms, it will gonna be 54 picometer. So the atomic radius of one carbon atom will be 54 picometer. So in this way we can find out the atomic radius of an atom. Now, what are the trends of atomic radius in periodic table? So, in my previous lecture, I have told you in details about periodic table. We have to consider periods and groups. So, here the horizontal rows are periods, while the vertical rows are groups. And I have taken 20 elements here because 1 to 20 elements are included in your syllabus. So now, if I talk about periods, by moving left to right in a period, atomic number increases, but the size of an atom decreases. In case of periods, the shell will not increase. Like if I talk about period number 2, so this is period number 2. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So, you can look over here that the shell is not changing. The principal quantum number will remain same in case of same period. Here I am talking about period number 2. So, in case of period, now the problem solved. Why atomic radius decreases along the period? Along the period, atomic number increases. Effective nuclear charge increases due to increase in number of protons. Shells are not increasing due to regular increase of atomic number. Gradual increase of nuclear charge pulls down the outermost shell towards the nucleus. So, atomic size decreases when we move from left to right in a periodic table. Trends of atomic radius in groups. Groups are vertical columns. So, by moving from top to bottom, size of an atom increases and atomic number also increases. But here the atomic number is increasing with intervals. If I talk about vertical columns, atomic number is increasing. So why the size of an atom increases down the group? Now addition of new shells, definitely when a new shell will come, it will take more place and the size of an atom will increase. And when electrons will move into outer and outer shells, they will also move away from nucleus and it will decrease the effective nuclear charge on electrons which are present in the outermost shell. So definitely the size of an atom will increase due to addition of shell and due to decreased nuclear charge. So that's all about atomic radius. Thank you so much.